Good evening, good afternoon, good morning. So, yesterday we had begun talking about oxidation and reduction reactions and oxidation states in chemical compounds. So, what I want to do today is continue along those lines because whereas CP gets sort of a very cursory view of oxidation and reduction reactions, we take it to the next level. We take it to a level where we're balancing them in acid solutions and in base solutions. And if we can get the basics down, it gets it's very simple when we get the basics down. But when we move into these other situations, you can at least see hopefully the rationale for what we're going to be doing. So once again, if you're looking at oxidation states, we had a whole set of rules, and most of them are really kind of obvious. For example, if I have an ion, the oxidation state is the same as the charge on the ion. So if I have Fe plus 2, Fe plus 2, the charge is plus 2 and the oxidation state is plus 2. So if I have Br minus, the charge is minus 1 and the oxidation state is minus 1. Where we get into some strange situations is if we have something like KMNO4, potassium permanganate, and we have this manganese in the middle, and we're not quite sure what we're doing here. We have to figure out the oxidation states for each of these so that if we look at a chemical reaction, we can figure out which is being oxidized and which things are being reduced. And remember, oxidation is the loss of electrons to give it a more positive charge, and reduction is the gain of electrons to give it a less positive or more negative charge, if you will. So in looking at something like this, we had some rules that had kind of a hierarchy. We said, well, unless oxide was involved with peroxide or somehow interacting with fluoride, it's minus 2. So in this case, we would have, well, 4 times minus 2, that's minus 8. Potassium is in group 1, so it's going to get a plus 1 charge. So my manganese here, let's just call it plus X. I don't need that there. It has to add up to the charge on the compound or on the polyatomic ion. In this case, it's a compound, so it has to add to 0. So manganese is going to be plus 7 oxidation state. And as long as you follow those rules, you're in good shape, and they're not difficult to do. Once again, that's what we're going to be referring to when we look at these. Okay, so that's determining the oxidation state. And then we would look at chemical reactions. Let's say, for example, I've got a chemical reaction like this. 2 strontium plus oxygen to give 2 SRO, 2 strontium oxide. And I say to you, which of the species are oxidized, which are reduced? Write the oxidation half reaction and write the reduction half reaction. So let's go and break this apart. Remember, elements in their standard states as they appear in nature have an oxidation number or an oxidation state of 0. So strontium is 0 there, and oxygen is 0 there. So far we've got that. That's pretty easy enough. Let's go on this side. Well, we learned that if something's in group 2, like strontium, when it becomes an ion, it will have an oxidation state of plus 2. Oxide, except for the 2 exceptions, will be minus 2. So we can look at this right away without having to write the half reactions, but we're going to write the half reactions because they become very important later. We could say that strontium goes from a 0 to a plus 2. It must have lost electrons, therefore it's oxidized. Oxygen had a 0 oxidation state. Now oxide minus 2, so it must have gained electrons. So let's go ahead and look at the 2 half reactions here. We've got strontium, and that's going to strontium plus 2 electrons. That's how we write the oxidation half reaction. Oxidation is loss of electrons. Another way to look at this is if I have an oxidation reaction, the electrons are on the product side of the arrow. That'll help you to figure that out too. And now let's take a look at this O2. Now don't be frightened because it's a diatomic element. Draw the arrow. And on this side, I'm going to have 2O with a -2. Right? So you might be thinking, well, how many electrons do I need? Well, look at it this way. The charges have to be the same on both sides of the arrow. So 2 times -2 is what? -4, right? So I have to add 4 electrons there. So this is the reduction half reaction because I'm gaining electrons. Those 4 electrons are coming in to the oxygen molecule and forming 2 oxide anions. Okay. Now, this, let me label this. This is the oxidation. This is the reduction. Now, let's say, for example, I just had these 2 reactions, and I wanted to add these 2 reactions to get the overall reaction. We can do that, but in order for us to do that, we have to make sure that the numbers of electrons in the oxidation reaction and the reduction reaction are the same. We can multiply through, just like balancing equations, to get the same number of electrons. So the least common multiple between 2 and 4 is what? 4, right? Yeah. So if I multiply this by 2, that 2 is going to distribute, and when I add them up, lo and behold, look what happens. I get 2 strontium plus O2. The electrons are going to cancel because you don't want electrons in your overall reaction, and that's going to give me 2 strontium, 2 oxide, or 2 SROs. So by doing that, by making sure the electrons balance and then adding them up, I get the overall reaction. So there's another built-in check there to make sure you're okay. This idea of half reactions is going to become very important probably next week. Okay, so don't discount this. Okay, now I'm going to give you some vocabulary. Oxidizing agent, move my head out of the way, and reducing agent. Now this is for some reason, this causes people some confusion. What do you think it means to be like an agent?
Spy.
Spy, right? Someone working for the other side, right? An IRS agent. Ooh, better not say that.
Insurance.
Insurance agent? Yeah, sometimes they work for you. Sometimes they don't, right?
I don't know why it's on video. I owe a lot of taxes.
I love the IRS and I love the government. Really. So, if something is oxidized, the thing that's causing the oxidation is the oxidizing agent. If something is reduced, the thing that is leading to that reduction is the reducing agent. So it's just the opposite. So strontium here, we can all agree, is being oxidized. It's losing electrons. Those electrons have to go somewhere. They're going to go to the oxygen. So strontium is the reducing agent, even though it's being oxidized.
It's doing the reducing.
It's doing, yeah, it's saying, here oxygen, I got some electrons for you. So it's going to be the agent that causes the reduction. Now, the oxidizing agent is the thing that causes the oxidation. So the thing being reduced is the oxidizing agent. More kind of vocabulary that's meant to confuse you in the world of chemists. So but
what's being oxidized is reducing?
What's being oxidized is the reducing agent. What's being reduced is the oxidizing agent. It takes.
So
They
you
just have to know what's
Yeah,
being
it's just
oxidized.
opposite.
It's exactly opposite. So if I said to you, name the reducing agent, well, the thing that's being oxidized is the thing that's giving its electrons to the other species, causing the reduction. So we call that the reduction agent. And believe me, even after 1,000 years of doing this, I still might misspeak sometimes and say the wrong thing. So let's take a look at another example or two and see if we can wrap our minds around this. Okay. So I'll do one, and then I'll have you guys look at a few. Let's take a look at. This is a good one. Okay, what? It's okay, Biden. I'm just making a video for the entire world to see. No one watching.
Talking about the IRS.
I love the IRS. I want to be an IRS agent when I grow up. So, anyway, let's take a look here. First of all, if I had to classify this kind of reaction, what type of reaction would it be? Double replacement, single replacement, combustion, acid base, blah, blah, blah. What would it be? Single replacement. Element plus a compound is a different compound plus an element. Yes, Anna?
If Mg had something bonded to it, that would be right.
Yeah, like say if this was like magnesium, whatever, nitrate, you could potentially make that a. Yes, that's the short answer. Yeah. If this was a compound and that was a compound and they switched partners, we'd have double replacement. So let's take a look. You don't even really need to write those half reactions to realize what's going on here. This is an element in its standard state, zero oxidation state. According to your rules, magnesium is a group 2 element. So when it becomes an ion, it gets +2. Charge is the same as the oxidation state. So without writing a half reaction, we could see that this was an oxidation, had to lose 2 reactions. So that part's taken care of, although we're going to go ahead and write the half reactions. Let's take a look here. What is the oxidation state on hydrogen here? It's bonded to a non-metal, +1. Hydrogen as an element.
No.
0, right? 0. So we've gone from a +1 to a 0, so there's been some reduction taking place there. Now let's go ahead and write the half reactions. Okay. Magnesium going to magnesium 2 plus 2 electrons.
What about the 2 in front of the HCl?
We're going to take care of that in a second. Magnesium going to magnesium 2 plus 2 electrons. This is the, which one? Oxidation or reduction? Reduction. Oxidation? It's oxidation.
Wait, are you talking the agent?
It is
No, we're not talking about the
Okay,
agent.
So then it's so when we oxidize.
It's an oxidation half reaction. Yeah, oxidation half reaction. Very good.
It's the reducing agent.
Yes, it's good. Magnesium is going to be the reducing agent. So that's the oxidation half reaction. Now, Anna brought up a really good point. We can't ignore that 2 there. 2H plus 2 electrons to give H2. That's the reduction half reaction.
Where did the Cl go?
Cl just floating around doing its thing because it doesn't change. It doesn't change its oxidation state. What is it here? Cl -1, right? Because it's just a chloride ion. I've got 2 of them. How about over here? It's just an ion.
We just know that because of the period.
We know that because it's magnesium chloride. Yeah, so -1. So that's a good question, though. Where does the chloride go? It doesn't go anywhere. It's just going to be.
We write the half reaction. We don't write the chloride.
We don't have to write the chloride because it doesn't do anything. It's not part of anything. Okay, so magnesium, this is the oxidation reaction. Magnesium is the reducing agent. This is the reduction half reaction. Proton here, the hydrogens are the oxidizing agent. Yes. Okay, so now I'm going to give you some to try. So please, nobody watch this video.